Good morning, professionals. My name is Samir Sullakar. I am from the construction chemical industry. I thank CIDC for this excellent initiative for the revival of economy from this hardships and the hard times that our economy is going through at the moment. I also thank CIDC for giving Construction Chemical Manufacturers Association an opportunity to use this platform to put forward the new technologies which are more relevant during and after these times. I shall be talking to you on stopping the leakages by injections, which is one of the technologies which can help, during the construction as well as after the construction. Basically, I am a civil and a structural engineer by profession. I have spent about 40 years in this line of construction chemicals in India, Europe, and at other places. And this is my line of specialization. And I feel construction chemicals is a good line or a good field in which many new engineers can include themselves and even become entrepreneurs because the entry barriers are very low. As far as underground leakages are concerned, they are unstoppable during construction as well as after construction. We are talking about the concrete. In concrete, we'll always find the cracks and the capillaries. There are cracks. These cracks are the avenues for carrying the corrosion controlling constituents to concrete. So they have to be sealed from the point of structural as well as from the point of durability. These are the photos after repairs. Though we conduct repairs to enhance the durability, still in reality, the motors that we are using are not shrinkage free. So they create these lines, once again, which are the avenues for entry of corrosion ingredients, as well as while repairing, they will not stop the process of corrosion. There are cavities in concrete, which is also important to be filled. It's a different type of cracks in concrete. You are aware of it. There are longitudinal cracks. There are cracks by uh, different damages by mechanical means. There are surface cracks. At the end of the day, we have to take care of all these cracks. Also, I would like to say that it is not adequate to stop the cracks and put the injection material inside the concrete alone, because the source of water is behind the concrete, and that is the soil concrete interaction. We have to also take steps to stop that leakages or to stop that source of water to a reasonable extent, so that we can keep that source of water far away from the concrete to let the water inside. And injection technology gives you a chance to go into the to go behind the structures, to go into the soils and put a stoppage to the water permanently as well as temporarily during the construction and permanently during the life of the structures. Third important point is the joints. Joints are provided by design as well as joints are there by virtue of the construction problems. And these joints become avenues from where the water can leak. And however, we have taken all the precautions. It bypasses, the systems are bypassed, and these cracks, the joints are open, and water also comes from the joints. So the injection technology also provides for recreation of these joints. So main applications in the geotechnical engineering of the injections are in sealing, consolidation, and filling. So this technology comes handy during construction and after construction. Fortunately, there is a code EN 1504 which fully covers this whole gambit of repairs and rehabilitation, and also it covers the materials for injections. Before 10 or 15 years, whenever someone said about injections, we always thought it is an epoxy injection. We used to use epoxy injections a lot at that time to structurally regain the strength of the concrete wherever there are cracks, structural cracks. But epoxy has its limitations when it comes into contact with water. So this limitations is also filled by several other materials available. At the moment, whenever you start talking to people about injection, the first thing they start talking, oh, you mean PU, you mean PU foams. Please note, PU and PU foams is just the beginning of injections. These are purely temporary methods to stop the water, to enable you to seal the crack permanently. So this is not the end of it. There are different materials available, and these are to be classified. A good geologist and a good civil engineer, with the help of the existing codes of practice, he has to make a decision whether in cracks you require a ductile filling, or you require a force transmitting. Force transmitting means where there are structural cracks, where you used to use only epoxies, and due to the limitations of epoxies, in the conditions where there is water in the concrete today, there are structural polyurethanes which can be injected, which are more flexible compared to epoxies. So this can be also used by repairing the girders of the bridges where there is a vibrational loads. And finally, the swelling or just for the filling, you can also use the formed materials, which are either gels or silicate foams or polyurethane foams. So a large gambit of materials are available, but these are to be selected depending upon very, very few important things, which is the crack width, because crack width will determine the viscosity. Crack depth will also determine the viscosity, how deep you want the material to penetrate. It will totally depend upon whether the crack is dry or whether it is damp or whether water is coming out of it. If the water is coming out of the crack, you have to really stop that water incoming by putting a pressure with your machines to push back that water and the injection resin to reach the place where it is designed to reach. The crack movements, whether the cracks are moving on there or they are not moving. What is our target solution? We are doing the injections for structural stability, for load transfer, or only we are doing it for the preserving the durability for sealing. The applicability, the locations, the applications, whether we can take big machineries inside the project. So there are several different parameters connected to this. So this is a technology by itself. This is not only a technology of materials, it is also a technology which involves the machineries. And only by combination of good materials, good application technology, and with trained applicators, one can do successful injections. This is just to give you an idea. Viscosity, as I said, is very, very important. If you see water is having a viscosity of 1. And water can penetrate, water is what has already penetrated. So we have to have materials very close to the water penetration so that we can counteract with the effect. If we take gels are very close to water. They can penetrate and their viscosity is less than 10 MPa. When you talk about epoxy resins, you are having a very wide range of epoxy resins. So every epoxy resin is not for injection. From 17 to 100,000. This is very, very important. Silicate resins, they are also excellent from 90 to 330. So viscosity plays a very, very important role. The urethane resins, the polyurethane resins are having much lower viscosities in the cases so that you can really inject it inside deep cracks. You can reach the, you can use it as a filling, cavity filling injections. Just to give you an idea, honey is 10,000. Normally you cannot inject a material when it crosses 500 or reaches 700 viscosity. Other thing which is important is what offers the resistance to it is mostly the concrete. The surface tension is also important. Lower the surface tension, the more is the penetration. The less is the resistance required, the less is the pressure required to push these materials inside. While doing injections, it is not sufficient if those of you who have seen this injections of grouting many years back, you would be seeing some pipes are being tied, the pipes are bent, then they are tied with some bands. No, the connections has to be mechanical. There are different types of packers are available. Any length of packer, we can today inject as much as 75 or 100 meters or 200 meters below the ground with special lenses which can be connected to every meter. They are perforated. We can take the material until so many 75 or 100 meters below. We can make the material mix with each other at the point of injections. There can be specialized mixers. So pot life is not affected. So we have to use these connections. What is most important about the connection is the pressure that you put through machineries is not lost due to bad connections. You require also sophisticated machineries which are designed. For example, when you have a very small pot life injection which has to react with react with each other within say a minute or less than a minute or even a few seconds, like 10 seconds, then you need a 2-component machineries. You cannot put both the materials in one component machinery. So you necessarily require two component machineries. Now these 2-component machineries, and when you use polyurethanes are sensitive to moisture. So these machineries should be so designed that there is no moisture which is penetrating. So polyurethanes is not the foams alone. Polyurethanes is foams is the basic thing, like 1-component foams which are used for a very low pressure injection. So this is how it forms. The moment the material comes into contact with water, if you put a 1-component foam, it starts foaming. This can foam. Now this is very, very important thing what I'm saying. This can foam from 5% or from 3% up to 75%. So when you are purchasing the foams, it is very, very important is what is its expandability. The unit price is not per kilo price or per liter price of the foaming material, but it is the cavity that you are going to feel. It is also important the foam is hydrophilic, hydrophobic, whether it is open cells, whether it is closed cells, whether it is homogeneous, in how much time it starts foaming. This will be all dependent on the type of the projects that you have. So this is a basic foam, which is 1-component foam. 1-component foam is suitable for only temporary stopping of the material where the heads are not high, and because the second component, it's reactivity with water, which you cannot control. If the water is cold, it doesn't expand. You cannot control its setting times. and it has got a limited applications. If in case of structures like tunnels, if you see, the water will be gushing. Now, with this type of water gushing, which is more than 6 bars, you can imagine yourself if you start injecting this with cement or cementitious materials or even one component foams. The pressure of the water which is coming is a 6 bars pressure. You will not be able to stop with one component foam, even temporarily. Let us not talk about the permanent stopping, but even temporarily. So primarily, you will have to go in for two component injections, because two component injections have got controlled reactions. They are little bit hard compared to one component. The foaming capacity is less. Maybe the foaming capacity is up to 14 or 15. So they can really stop this water when you use real proper machineries to push this materials inside. So this is how from one component material you become a two component material. Then there are flexible materials, ductile filling materials. When you are talking in terms of pushing these materials in the cracks, in concrete, in podiums, and in other structures where flexibility is required, polyurethanes are very, very, very flexible. You can inject them. They are not sensitive to moisture. In cases like this, which you will normally see in basements, in underground, in parkings, you can see the water coming inside. This is the method of injection. You have to drill the holes at 45 degrees angle. You have to put the mechanical packers inside it, fix those packers so that the material reaches the center of the crack, and then start injecting the material with proper machinery, with proper connections. Here you can use the ductile filling material. These are two component polyurethanes, but these are having also limited structural capacity. Their aim is to seal these cracks. Their aim is not to increase the strength of the concrete, or this is not force transmitting injections. But these are also important in injections for podiums, for parking places. And then comes the most important, there are two component structural polyurethanes. Structural polyurethanes develop a strength of 70 to 80 Newton per mm square. So you can replace them with epoxy injections, even in cases of dry cracks, so that you don't have to mix with too many materials. They can be used underwater. There is no problem of hardening. They are not sensitive to moisture. Their foaming can be controlled from 1 to 15. They have a very high bond strength, very high shear strength. And this is very, very important for either for soil consolidation or force transmitting cracks. And these are the materials. So polyurethanes alone, foaming polyurethanes, is not the end of the story. It is just the beginning of story. So even if you do the temporary stoppage of water, if you do the temporary stoppage of water by one component foams, for permanent stoppage of water, you will have to go for two component structural injections. It's just demonstrating it to you how it works, because this structural injection can be used in the existing structures, as well as they come a lot handy when you are building things like tunnels. In tunnels where your geological examination is already shown that maybe 70 meters ahead, you are already having a fractured rock from where water is coming. Now you cannot stop your TBMs going. So this comes very handy.
Hello and good
You also
morning.
please that is
I'm
you just
Himanshu
inject it.
Kapadia,
If you see that
and
it is in gravels with are been put, the water is coming from top, and on the right hand side is second and fraction of seconds. So you start injecting a structural polyurethane. It's only 7 seconds. First thing, the speed of reaction is very, very important. In 7 seconds, in fractured rock, you're putting the materials. In about 17 to 20 seconds, that much, or 20 seconds or 30 seconds is required, so that the material can spread all around. Because you cannot just make it set within 1 second or 2 seconds, because the material has to also spread all around. Then it has got a foaming capacity. When it comes into contact with water, its reaction starts within about 30 to 40 seconds. The reaction has slowly started, and it is a structural permanent solution. If you see now, the water has stopped going inside and the water is raising. If you see from the bottom, the stream of water is getting reduced. It has expanded, not very much, but to the reasonable extent so that it is spread all around. The water from top is flowing out. The water which is coming out with gushes, it is now slowly stopping. And within a matter of 1 minute, the total process is over. This is can be similarly used in our basements. We are having a lot of problems in our basement. The water comes inside and you cannot stop it by foam. If you stop it by foam, tomorrow, once again, once the foam is thrown out, the foam is not durable. These materials are tested for durability of 100 years. There are long-term tests been done in field of about 20 years, and then by extrapolating, these materials are very suitable and remain almost permanently, which is very, very important. Foam is not stable. Foam does not have a capacity to bond to your concrete. Foam does not have the water pressure bearing capacity. So this different polyurethanes are very, very handy when you try to stop water during construction. For example, this is the type of the water. You can try to put any foam inside, which is expands 50 times or 40 times. It cannot stop the water. Because to stop this type of water coming under such a pressure of 6 bars or 10 bars, you really need polyurethanes which are structural, which can harden totally underwater within a period of 1 to 2 minutes. So totally your construction can go unabated, as well as it forms a permanent seal. It's a permanent solution. If you see the water is going on reducing in a matter of just minutes. So this is the real live stopping of water. So within about 1 or 2 minutes, the flow of water is reduced. And these are the only means of providing permanent solution during construction as well as after construction. Still more versatile resins are the two components silicate resins. There are also polyurethane is not the end of the story. There are silicate resins. This is organo-mineral silicate resins. Silicate resins, there are also foaming silicate resins and non-foaming silicate resins. Silicate resins bond very well under wet conditions. Silicate resins, they also foam structurally. Say 1:3, they can be used for the lifting of the structures. So they can go very nicely inside the soil and do the stabilization. They are structural. They can be also used for example, for the same purpose that we use the polyurethane injections. If there is a very fractured rock, we can once again, and there is no water, there can be a fractured rock with water where you need polyurethanes, because polyurethanes form only in presence of water. Whereas as far as silicates are concerned, silicates form on their own and they can glue. They can glue this fractured rock, especially during constructions. You see here, this is now already injected. This foam with restrained expansion also develops sufficient structural strength. So when the machine passes through, it offers enough resistance. You can see the very fast foaming. Even if there are some remnants of water, it will throw away. These are also available. These are mostly used on TBM machines, and this would be a good example to show a tunnel boring machine. When the tunnel boring machine is moving around, geotechnical surveys have already identified that X meters you are having. So you are already putting in the silicate foam. It cannot move. The shield cannot move. So the silicate foam is silicate foam is injected. This foam is not injecting 50 or 60 times. Within 45 seconds, this has got, they have maintained the foaming factor to 8 to 12. See, one thing you have to remember, you'll see some certificates which will tell you my foaming is 1 is to 15 and my compressive strength is 15 Newton. This is not possible. Because on one foaming factors they give is a foaming factor, the tests are done with only 1 is to 1 or 1 is to 3 foaming factors. So you can't have both the things. As the foaming increases, as the foaming increases, the compressive strength decreases. Now these foams are also excellent for soil nailing. You have inside you have the soil nailing, say about 15 or 20 meters. You got self-drilling anchors. It's a very, very versatile material. It doesn't expand. In this particular case, it is non-expanding. It will slightly expand so that it creates a bond. If there is a water inside the structure, you cannot use the epoxies for fixing your anchors bar. Whether it is self-drilling anchors for soil stabilization or it is even transfer of loads in your RCC repairs to be done to foundation below the water, there you have to go in for silicate technology. So you shall be seeing now how many materials and how many parameters a engineer, a geotechnical engineer has to consider before just writing specifications, which I see in many dam specifications. He said repairs are to be done by 2-component polyurethanes. This does not say anything. The performance criteria should be given. What strength you require for repairs, what viscosity is required, in how much time, for example, this develops a pull-out load up to 20 tons within about 10 seconds, within about 10 minutes. Within about 10 minutes, your reaction is over. It is developing the full strength. And these are the resins that you have to consider as new generation resins, and a still more versatile development or still more versatile material are the acrylic gels. These acrylic gels, they are fantastic as far as the sealing is concerned. They have got adjustable pot life. You can adjust the pot life from 9 to 10 seconds up to 30 minutes, depending on the flow of water, depending upon the penetrability. They have got a very, very low, the lowest viscosity. They can penetrate to the finest possible pores. As good as it is, as good as water. Wherever water can reach, they can reach to. They're more important, which I will come on my last slide, which is very, very important. They should be approved for use in groundwater. There have been major accidents, which I will show you. You can go on the net and find it out. Under the name of gels, some wrong poisonous materials are still being used. You have to be very, very careful. They should have a groundwater clearance certifications, especially coming from European countries. There is a CE marking, there is a groundwater certification. You should ask for certificates, and there are durability certifications. There is a durability certifications for gels, also for 120 years. A testing in the field for 20 years. Please note, every gel is not a gel. Some gels, they will just become gels. After some time, they will shrink. Once they shrink, the joint or whatever it is very vulnerable to the water entry. So they react very fast. You can see within, they are having up to, when it reaches say 100, the viscosity of 100 MPAs, it is still pumpable. Then the reaction time, in about say 10 to 12 seconds, you can control it. Then it starts increasing in the gelation time, and it is gelled. Within about 20 minutes, it is a proper gel. I will show you one or two videos to show you the type of the gels. These gels are normal, as well as these gels are also can be fortified with acrylics to give it a characteristics which is so flexible, which you can convert it into a joint filling material. There are so many projects they are coming to us in this type of railway underpasses. The railway underpasses, they are normally made out of precast element having a depth of about 4 meters. They are 4 meters in the length, and the depth of about 60 centimeters. They are placed side by side. Sometimes the joints are filled by uh, some boards. Sometimes they are filled with some other materials, but they fail, and the water starts coming inside the roads. The roads become unusable, usable, and the gels are the only solution. Please note my words. I'm saying only solutions, only permanent solutions. Initially, you can put some foam inside to stop the water if it is coming in a very big conditions. But if you see these joints, sometimes there are water stops are provided in the two connecting things. Sometimes we put the styropor inside. Sometimes you pull the cyrodex or dimple boards inside. But by some chances, these are breached. The water still passes. The joints become very vulnerable. There are suggestions from the people saying that you use only foam, no problem. It is stopped. Of course, it will be stopped for 2 months or 4 months or 6 months because uh, foam is not a permanent material. Some people say you put some other polyurethanes inside, rigid polyurethanes or flexible polyurethanes. No, this won't help either because you have to create a joint sealing material. A joint sealing material should have a adequate bonding on the sides. Joint sealing material should have enough elasticity for expansion and contraction, and it should become a seal. Joint sealing and joints, because this is very very important. So any other method won't work. So over a period of time, when you use the gels, you inject. You can see it is such a simple process. It's a single step process. You make the simple one step process into 4-step process or 5-step process, or put some injections inside, put some foams inside. Okay, you can still put some foam inside to stop the water initially, but permanently what is important is a gel which will set inside. This material is also very very important in precast joints. In precast joints of the segments, you have already gaskets put inside. However, due to the constructional problem, these gaskets are not 100% waterproof, and the water starts coming in through gaskets. But please remember, at the end of the day, they are joints. You can inject through the joints by needle injections. Also, you can inject it from two different sides. You don't have to puncture. Sometimes you can directly puncture the gaskets, go behind it if the water stop is less, water not stop. If the water entry is less, if water entry is more, you can do it through the packers, which are put at 45 degrees. They go behind your gaskets and then create the same thing what has been created. The same technique, you are going behind that physical barrier. Some physical barrier is should put. If they have not put a physical barrier, and if your width is 60 centimeter, you can put some Cyrodex board up to say 30 centimeters. So automatically you get a physical barrier. Go behind that 30 centimeter at 45 degrees angle. Inject a gel inside it. So a little bit of gel will come because there is not a sealing with the thermocol or Cyrodex board or dimple boards. Some material will go there. It is good for you. If you want more in sophisticated, if this comes in the factory floorings, you also have got a small portion kept above. You can feel a joint filler. You can seal that joint by polyurethane joint sealants or polysulfide joint sealants. So many joint sealants or polymer joint sealants, if it is to be used. But this is the basic techniques. There's no other technique, and this cannot be a temporary thing. I wanted to show you, for your interest, the material. What material is going inside? It is not enough a rigid material like polyurethane, which I showed you, goes inside. This is just to show you what is the material that goes as a gel. This is a fortified gel. This is just a tire to show you. You see, this is the material, two components. Simply we are powering to show you the type of the material. It gels within no time. Finished. The material is already started gelling. It has already gelled. It is a gel. It is a 3-component gel: A component, B component, an accelerator, and an fortified polymer. You can see here within seconds, within 10 to 15 seconds. And this is the material that is to go inside the joints. If you tell me you put any other rigid polyurethane inside, put a flexible polyurethane inside, within 10 minutes, Within 10 minutes, it has developed adequate bonding strength, which is most important. Any material you are using to recreate the joints in the segments, or to recreate the joints for the underpasses, or any other joint from where the water comes, a joint is a joint. It is to be treated like a joint. The bonding should be there on the sides, and it should have enough elasticity. You can see here within 10 minutes. That means any water that is coming, it reacts with water, and it is totally elastic. What is more important? What is more important is this material is tested with proper certifications, with proper certificates for a period of 20 years in the field. There are official test certificates are available for this, because the durability. Once you try to put something in a metro project, and the metro project is designed for 120 years, any material that you put behind should have. And also when these are below, you can see it has been tested for 7 bars. That means if you take a foam, a one component foam, even if the pressure is 2 bars, it will throw the foam out. If you take another 2 component foam, maybe 4 bars, it throws out. These materials are to be essentially tested as per EN 2504 to 7 bars, but they remain live even up to 12 bars. That means 112, 7 bars means 70 meter of the head. And the durability testing, these gels are liable to expand and contract inside when they are inside the mud, or inside that in connection with water. They can be tested. Now this has been tested up to 14 years in field. How much it is expanded, because when there is less water, it shrinks. When there's more water, it expands. If you see the cycles over a period of 14 years, and this can be extrapolated. This can be extrapolated, and engineering estimation of a durability of this gel is 120 years as compared to your PU foam. Or a PU foam doesn't bond to concrete. A PU foam cannot go inside the joint. It can't bond on the sides of the joint. A PU foam cannot be so flexible as what I said. PU foam cannot be living for 120 years. So if you want to do some permanent solution, these are the permanent solutions are available to you. And more than that, what I said, this has been tested. These have been tested for pressure and durability in field up to 12 bars. This I think there's a no-dig show going within simultaneously. There's a micro tunneling. Even if there is a water pressure line which is having a pressure of about 12 bars, and the joints are leaking, because they can be also built. They are micro tunneling, but they are also built in the segmental way. The water can go inside, which is very dangerous. Drinking water can go outside. There's only one way to stop it as of now: using fortified gels. It is not one component polyurethane. It is not two component polyurethane. It is not one component or two component flexible polyurethanes. It is not a two component structural polyurethane, because we need here a flexibility. We need here a good bond. It should remain under pressure, and we also need the durability. So these are the solutions available now on a simple example. If there's a basement, this is a basement which is done in Bombay. This is a 6-level basement. A 6-level basement in BKC, where the water was coming with this strength. And we use the same technique. Since more water was coming in the beginning, we use the polyurethane foam, a one component polyurethane foam or a two component polyurethane foam, to stop more water coming inside. And that is a temporary solution. You need to use a foam. A foam is a temporary solution. A foam is not a permanent solution. We used also some physical means. You put some rods inside. You can put some lead inside. You can put, because the water has to be stopped, because injection has to work. And then we are injecting, of course, with the knowledge of the structure, we are injecting with the knowledge, the expertise, with the trained applicators. This is 6 floors below 16 meters basement in Mumbai. And this can be stopped. The water can be stopped permanently. What is more important is a permanent stoppage of water, not temporary. They have done several trials for several years. So many people have come and injected so many things. A cement was injected, a polyurethane was injected, a rigid polyurethane was injected. So many things was done. But here also, what we have to finally create, we have to create a sort of curtain walling, a curtain behind the basement, a curtain behind the basement, which can be even for the 7 bars or 70 meters. So it forms a membrane. That was our trained applicator standing there with machinery, well trained. This machinery is from Italy, two component machinery. It is beginning for injection. You require an expertise. You require expertise. We offer trainings. This is a beautiful opportunity for the new engineers to go in for their uh, what do you call it, the internships, or become entrepreneurs. During this time, the jobs are less. We are injecting now behind the basement wall. We are not injecting in the concrete, we are injecting behind. So what we are doing, we are creating a positive waterproofing from a negative side. We are standing inside and creating a waterproofing layer outside. So our whole aim, it is not only stopping the cracks in the concrete from where the water is coming, but we are stopping the source of water. We are keeping that source of water away. And as I already discussed, there's a durability. A durability is guaranteed durability. It is not poisonous for any water, and the water is completely stopped and stopped permanently. I request you, please use these technologies. Please use your engineering knowledge. Please use your uh, geotechnical knowledge. Please use your civil engineering knowledge. Please use your common sense, civil engineering common sense, I would say. And the final use of the injections is also to do repairs of the infrastructures. You must be seeing at many places there is sinking of the slabs there is sinking of the slabs. That means the slabs, like runway slabs or the highways, they settle. Now, when they settle, you have to really see that which material can penetrate. So this is a guideline. You can see you are having permeabilities from 100 to 10, from 10 raised to minus 7. So differing on it depends on all different type of soils and are been put on one side. All the materials are put on one side. We can even go almost to the half the clay penetration capacity. Which material is to be used? This is a small handout or a guideline you can run. Which material can be used when water is there? Which material is to be used when there is no water? Which can set in water, which can set without water, which can set in water or outside water. This is for purpose of injection in soil. The reason I'm telling is when you are doing, these are the strengths developed. If you see a cement suspensions, micro cement, that develops a very, very less than after 24 hours. The strength developed is not even 10 newtons. After 28 days, because you are putting so much of water into the cement suspension, it's only 15. If you use a good concrete, after 2 hours it starts setting. But before that 2 hours, if the water pressure is high, it can be thrown out. But if we use the silicate resins, you can see within 1 hour or within 2 hours, it can develop a strength of up to 50 newtons. It is very important to select the type of material. This is where it is settled. Now, please remember one thing. This is a pure common sense. When something is settled, it settles because the bearing capacity of the soil is not adequate enough to take the surface loads. Now, this is very important. So, when you are trying to lift up the slab, lifting alone is not important, not enough. You have to first consolidate. Once again, this is engineering property. After consolidating, then you lift it and lift it properly. Then the problem will be solved. This happened to us in one of the quotations which we have given for a big project. They said the other person is doing lifting the slabs only at 20% of the cost. Well, lifting the slabs is not a big problem. The moment a lorry or the plane lands on it, since the underground soil is not consolidated, once again it will go down. Lastly, it can be used very effectively in dam structures, embankments. If there are streams going from upstream to downstream or the other way around, this water can be stopped by geologically, by georadars, knowing where are the streams. The surface can be stabilized by using acrylic gels wherever necessary. And this is most important things. I think this is one thing which you can simply go on the website and you just put Holland Das Tunnel project, and you will find this is the accident which took place in about 1995 to 1997. The name of the company which was manufacturing, they put about 14 tons of gel inside to stop the water from this underground tunnel. Fortunately, there was no loss to human life. This gel was poisonous. This gel is an acrylamide gel. It is poisonous. So please be careful. Everything that gels is not the end of the story. You can see here, farmers near the construction site started complaining about the cattle becoming paralyzed. They killed about 370 animals to stop giving adulterated milk, adulterated by cows themselves by ingesting this. Human lives did not get affected. 330, 29 wells were uh, poisoned. People could not drink that water. And this is very important. So this is not sustainable. So please get your certification. Say only because a product costs 100 rupees less, and if it creates this type of havoc, one has to be very, very careful. This project stopped for about 7 years and was, I think, between 2009 and 2015. It restarted and now it is completed, but it created this havoc. So at the end of the day, what is important is people need a good training facilities, because you have to have trained applicators, which we can provide. People can be trained by foreign uh, trainers, or people from India can be sent to foreign country for short-term training. Certification is very important. We need the help of CIDC to provide the certifications, because our own certifications are not that valid. If government can help us approve these trainings, those certificates will have a lot of validity. So many civil engineers who are new, they can go for internship for these injections. They can become entrepreneurs. They don't have to rely on someone to become, because they can buy one machine, they can get a training, and they can use it. Ultimately, once again, to repeat, this should be sustainable. Sustainability is the most important. Any technology that you bring to the country, please be careful. It is sustainable. It doesn't kill people. And polyurethane injections is not a polyurethane alone. Injection is a wide gamut of. It is an engineering field. You require a technical knowledge. The universities can start courses. The professors can learn more about it. They can have hands-on experience. So I thank once again CIDC, who is making attempts to revive the economy, and this type of materials will be needed, because now we are going for more and more underground constructions like metros, hydroelectric projects. And please note, by use of engineering knowledge, by use of engineering materials, the problems can be solved, and the constructions as well as the completed constructions can live peacefully for more longer time. Sustainability and durability is the key. Thank you very much. Thanks.